personal finance practice problem using OneNote. College savings calculation. Prepare to get financially fit by practicing personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side, the Practice Problems tab, down in the 1180 College Savings Calculation tab. Also note, when using OneNote, take a look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got the information up top, calculations on down below. We're looking at a college savings type scenario. There's two kind of factors that we're going to be taking into consideration, or that you might consider if you were to save up for college. One is, how much do I need in terms of a lump sum once college starts, and are at the situation where I'm going to be dipping into that lump sum over the time period that college will span, which we're going to assume to be 4 years here. And then two, once I know what that lump sum is, if I'm saving up for that point in time, how much money do I need to save either periodically or at some point to get to that point where I can start spending it over the 4-year time period. Here, we're considering what needs to be considered generally first when you go through the planning process, that being how much would be needed kind of at the start of college if you were going to consume it at that point in time. So here's what we have. How much would have to be invested to be able to take out each year for costs? $25,000. So in other words, we're going to imagine we have a lump sum amount of money and we're going to be taking out $25,000 a year for 4 years, while the amount that's still in the account should be getting an average return, or return we're saying, of the 6%. So we're imagining once the college point starts, then we're now basically going to be dipping into the college funds. Now, of course, you could have other factors involved with college, like student loans and that kind of thing as well, as you consider this type of calculation. But here, again, we're thinking, how much money do I need if I'm going to be taking out $25,000 a year for 4 years, 4 periods? Now, obviously, you might say, well, the first kind of guess would be, well, I would need 25,000 times 4, which would be 100,000, because I'm going to be spending 25,000 a year. But of course, if we had that lump sum already input, we wouldn't need the full 100,000. It'd be something closer to, we're saying, 86,627, due to the fact that during that 4-year time period, the money that's still in the savings account should be generating a return on it. Now, this one can be a little bit confusing because we're kind of projecting into the future what we need. So you might think, well, that sounds like a future value type of calculation. And you probably would think, well, it sounds like an annuity, because we do have 4 payments that are, 4 amounts that are the same. And but then you might think future value. But really, we're kind of trying to pull that back to the present period. And when I say present period, I mean the start period at which you'd be starting college, which then, if you were planning to save for that amount, you would then have to be thinking about how much you would need to save to get to that point in time. But again, we're bringing it back to the present period, the starting point. How much would then be needed? So that's going to be a present value of an annuity type of calculation. Let's first consider that with the Excel formula. We do work this problem in Excel if you want to take a look at it there, but we'll just go through the calculation this way. We've got equals, and I'm going to say negative in order to flip the sign. Otherwise, the result would be a negative number. We want a positive number, so I'm going to put the negative in front of the P here. You could also put it in front of the payment. Then we're going to take the rate. The rate is referencing this 6% up top. It's useful to have a cell reference in Excel so that we can change our data set if we want and run different projections with it. Comma, then we have the number of periods, which is referencing the 4 periods here, because we've got the 4 years that we'll be dealing with. Comma, and then we're going to be using the payment field because it is an annuity. The payment's going to be that $25,000. The present value then resulting in the 86,627. Therefore, the assumption being that if we have the 86,627, we're earning a 6% return on what is still in the account, and then each year we're pulling out 25,000. Hopefully that should be enough then to cover the 25,000 a year over the 4-year time period. In order to solidify that in our minds, what's useful to then take a look at is the running balance calculation. These are the 2 steps that you would probably do in practice to get your mind most clearly wrapped around this. Then you can go into, after that, the calculation for the mathematical formula that we will take a look at, and the tables, two kind of formats that would more likely be involved in a school type setting. So if we had a running balance calculation, we got the periods from 1 to 4, and we can imagine that we have the investment then at the 86,628. So we're starting at the 86,628 here, and then we're going to see what happens over the 4-year time period. If everything works the way it's supposed to, at the end of this process, after the 4 years, we should be down to 0 exactly if the calculation is making sense to us. So we're going to say if we've got the 86,628, can I make this any smaller? I can make it way smaller. All right, we got the trusty calculator. This is going to be the 86628 times the 0.06. That means we're going to be generating revenue of the 5,198, but then we're going to take out 25,000 for the college. So that's going to be leaving us after the first year at the 86,628 plus the 5,198 minus the 25,000 at then the 66,825. So clearly what's happening here is that we're still generating revenue on the balance, but we're taking more money out than the revenue that we're generating from it, and therefore we have the investment going down. As the investment goes down, it's going to generate less money or less revenue each period, given the fact that there's less money invested. So then we have this amount, the 66,825. We're going to multiply that times 0.06. That's going to give us the 4,009, 4,010 about. Then we're taking out another 25,000. So we then have the 66,825 plus the 4,010 about minus the 25,000. That leaves us with only the 44,835 about left. Then we're going to do this again. We're going to multiply times 0.06. That gives us about. Rounding is involved here, the 2,750. That's income we would earn on it. But we're going to be taking out another 25,000. So if we calculate that, that's the 45,835 plus the 2,750 minus the 25,000 is going to give us this time the 23,585. And then finally, taking that times the 0.06 should give us the 1,415 about. And then we're going to take out 25,000. So that 1,415 about plus the 23,585 gives us about 25,000, which results in 0 at the end of that process. So if we had the 86,628 due to the earnings that we have over the time period for the amount that's still in the account, we should be able then to take out the 25,000 and have it cover the full 4-year time period. So let's do it again, this time with the annuity calculation. So we got the annuity calculation up top. We have the P equals the payment, which would be the 25,000 times 1 minus 1 over 1 plus R, which would be the rate of 6% to the number of periods N, which would be 4, divided by R, which would be 6%. You can plug that in and do it algebraically. We're going to do it down here in the table as we have been practicing with, although this is kind of a long, complex table type of problem. We're going to have these two outer components on the outside. Then we're going to work the inside with this numerator for the most part, pulling that in as we get more complex in a similar fashion as you might see with a tax return, or in a fashion you might see when you're formatting financial statements. So we're going to say, all right, we got the payment up top. That's the payment. That's going to be on the right-hand side, 25,000. We're going to pull inside the numerator, this whole top piece, and then we're going to have a 1, which is going to be this 1 right there. And then we're going to have the numerator 2, which is that 1 up top, which I'm just going to put the 1 right there. And then the denominator, which is the 1 plus R to the N, which we're going to pull inside, indicated by the colon and the indentations down here. We then have 1 plus R. R is 6%. So 1 plus 6%, 100% plus 6%, or 1 plus 0.06 is 106%, or 1.06. To R, to N, which is 4, is then going to give us then this decimalized number. Let's do that with the trusty calculator. To do that, we're going to pull up the scientific calculator, though, so that we can go to the power of 4. So we got 1 plus the 0.06 is going to give us 1.06, which is 106%, to the xy, or the caret, or the power of 4. And that gives us our 1.262477 about. Back to the normal calculator, the standard calc. So there's our standard calculator. And so then that went up here. So now we've got the 1 divided by that, which is in this column, 1 divided by this thing that we just got down there, the decimalized number. 1 divided by that thing, 1.262477, gives us about, if we make the calculator a little bit larger so we could see it, 0.792094 about. So that's this whole thing. And now we're going to take 1 minus that thing that we just got. So 1, it's in this column, minus that thing we just got, all in the same column here. So let's do that. 1 minus the 0.792094 about gives us about 0.207906. So now that's this whole numerator thing here. So now we can divide that by the denominator, which is R, we said, right? R, which is 6%. So we'll take that decimalized number divided by 0.066%, gives us about 3.4651 about. And now we can finally multiply these two things together. Outer column, 25,000 times that decimalized number. So times 25,000 is going to give us, finally, 86,627 about. Pennies here are more exact given the fact that in Excel we have more exact numbers as it will be calculated using the whole decimalized number, even though we can only see so many decimals when we actually visualize how many decimals we want to see in it. So then going down, let's do the same thing with the tables now. Table time. Pretty straightforward table problem as long as we pick the proper table. Remember, there's typically 4 tables, 2 present value, 2 future value, both of them having an annuity and non-annuity. We, of course, here are looking at the present value annuity table, and then we want to look at the range of 6% and 4 periods. So we're looking 6 and 4. Here's the 6, there's the 4. We're looking 3.4651. 3.4651. There's the 3.4651. Let's multiply it out. 25,000 times 3.4651, giving us the 86,627.5. Note that this table is rounded to 4 digits, and so that's why we might have a slightly different number, 86,627, compared to the 86,627.60 versus the 50. Due to the rounding, the actual number is more like the actual number is more like this 3.465106. So you can see it goes past 4 digits, and therefore the tables will result in a small rounding difference, one which not generally applicable for most of the purposes we use it for actual practice, but one which can be utilized on a test if they want to determine which method you used to do the calculation.